Okay, for what we have in section 2.2 as a sample problem that we have in Aleks online, okay, we have looking at solving for x, and here we have 6x minus 12 quantity, and we have times the quantity of x squared plus 8x plus 7. And we have is equal to 0, and now these terms or expressions I can factor. Now for 6x minus 12, if I were to factor, I have 6 times the quantity of x minus 2. For x squared plus 8x plus 7, if I factor, I have the quantity of x plus 7 times that of x plus 1 is equal to 0. Now we have 4 factors, but only 3 are in x. So we have, upon utilizing the zero product property, if I set the x factors each equal to 0, if x minus 2 is equal to 0, I have x is equal to 2. If x plus 7 is 0, I have that x is equal to negative 7. And as for x plus 1 is equal to 0, I have x is equal to negative 1. So in carrying over to what I have here, and we have x at 2, negative 7, and negative 1. And if I check the result, and for the feedback, okay, this result is correct. Okay, now we have, as a second problem, it says suppose that the polynomial function f is defined as follows. And here we have this function we have in factored form, and we have f of x equal to 4x times the quantity of x minus 13 times the cube of x plus 7. And it says to list each zero of f according to its multiplicity in the categories below. So we're looking at zeros of multiplicity 1 and 2 and 3. Now, for what we have in the case of this item, okay, so we have f of x, and we have is equal to 4x times the quantity of x minus 13. And we have times the cube of x plus 3. And if I were to determine the zeros, okay, so we have with the factors here. So we have with x, if I set 4x equal to 0 or just x equal to 0, have x is equal to 0 for x minus 13. If I set x minus 13 equal to 0, I have that x is equal to 13. And we have, in the case of the cube of x plus 7, if x plus 7 is equal to 0, I have x is equal to negative 7. And for what we have in the case of the multiplicity, okay, and we have in this one case, you have x equals 0 stems from just x, which you could regard as being raised to the first power. So you have that multiplicity is 1. X equals 13 is equal to the quantity of x minus 13. There's no explicitly raised power. And you could read this as the quantity of x minus 13 to the first. So 13 has a multiplicity of 1. Negative 7 stems from x plus 7 to the third. And we have with that degree, this signals that negative 7 has a multiplicity of 3. Now, for the zeros of multiplicity 1, I have 0 and 13. And since I don't have any square expressions for the zeros of multiplicity 2, okay, and we have in this result, okay, so I have none. And for the zeros of multiplicity 3, okay, that is going to correspond to negative 7. And checking the result, okay, and that is correct. Okay, now it says to find all the y-intercepts and x-intercepts of the graph of the function, where we have the function is f of x is equal to 2x cubed plus 12x squared plus 6x. And we have for this one, okay, so you have y is equal to f of x is equal to 2x cubed plus 12x squared plus 16x. Okay, and if we were to look for the y-intercept, okay, and again we have for the y-intercept you're setting x to 0 while solving for y. So we can say we have y is equal to f of 0, and if I set x to 0, now for the y-intercept, okay, what we're going to have in effect, okay, is that for our y-intercept. Now we're not going to put this in coordinate fashion. We'll just put this in terms of what we have y set equal to. Okay, so that is going to be at 0. Now, on the other hand, okay, now in looking at solving for the x-intercepts, this time we're looking at solving for x as y is set to 0. So we have that 0 is equal to 2x cubed plus 12x squared plus 16x. Now we have among the terms, now the greatest common factor is going to be at 2x, and we have 2x into 2x cubed, so that's going to be x squared plus 6x plus 8. So we have a trinomial that can be factored. And if I set each of the factors to 0, all right, so we have a 2x, have the x factor, x plus 4, and x plus 2. And if I set to 0, so for 2x equal to 0, I have x is equal to 0. For x plus 4, I have x equal to -4. And for x plus 2, if that is set equal to 0, I have x is equal to -2. So we can say that for the x-intercepts, okay, now I'm not going to put in the y-coordinate, just the values of x. So we have 0, -4, and -2, and checking the result, and that is correct. Okay, for what we have in this problem, now we have a function f of x. And we have is equal to the quantity of x plus 2 times, okay, the square of x plus 1. We have times the quantity of x minus 1. Now, starting out, now we're looking at the end behavior of the graph of this particular function. And so we have for the leadoff term, okay, so we have okay, with this item, I have a function f of x is equal to x plus 2, quantity times quantity of the square, or to say the quantity of x plus 1 raised to the second. We have times the quantity of x minus 1. And we're looking at the end behavior. Now, in taking what we have now, if we look at the highest degree term, all right, so looking at the factors, okay, so I have x plus 2, higher order term is x. Then for x plus 1 squared, higher degree portion is an x, and that will be to the second. Then we have x minus 1. So looking at what we have now, from the first factor, I have x. From the second, I have x to the second. From x minus 1, I have x. X times x squared, okay, times x. And here we have x times x squared is x cubed times x So this will be x to the fourth. Okay, so if you notice for the leading coefficient, okay, you have implicitly that a of n is equal to 1, so that is positive. And we have with the degree n, okay, that is going to be 4, which is even. If you have a positive leading coefficient and the degree of the function is even, now the end behavior, you're going to have up to the left and up to the right. And in looking at what we have here, in choosing the end behavior of the graph, okay, so rise and refer to going up, fall means going down. And since we have up at both ends, this means we'll have rises to the left and rises to the right. And now, in terms of the end behavior, again, you have up to the left, up to the right. Now, again, just looking at the factors. Okay, so we have with the zeros. From x plus 2, I have x equal to negative 2. For x plus 1, I have x equal to negative 1. And we have from x minus 1, I have that x is equal to 1. And as for the multiplicity, okay, so x plus 2, you have to the first, x plus 1 is to the second, x minus 1 is to the first. And in terms of whether the graph touches or crosses the x-axis, we have x equal to negative 2, which has a multiplicity of 1. And since 1 is odd, that means you have the graph to cross at x equal to negative 2. Since negative 1 has an even multiplicity with 2, the graph is going to touch at x is equal to negative 1. And with x equal to 1, with a multiplicity of 1, okay, the graph is going to cross at x is equal to 1. All right, so in terms of where the graph is going to cross the x-axis, that's going to be one location for touching, 2 locations for crossing. So we have at negative 2 and 1, where the graph touches but does not cross the x-axis. In this case, that will be at negative 1. Now, in the case of what we have with the y-intercept of the graph, and just going back, okay, so we have with our function, okay, so for the y-intercept, and again, this will be where x is at 0. So you might have 2 times the square of 1 times negative 1, 2 times 1, then we have times negative 1, so that is going to be at negative 2. So the y-intercept of the graph, and again, y-intercept will be where x is set to 0, so we have at negative 2. Now, in the case of graphing, it says to graph this function by plotting all the points where the graph of f intersects the x-axis or y-axis. Okay, so we have with our x-axis points, okay, we have at negative 2. Also, we have, you also have looking at selecting. Okay, so we have in the case of the end behavior, again, you had the end behavior have rising to the left and rising to the right. Now negative 2 is going to be the leftmost 0, and here at negative 2, so you have in behavior have rising to the left, but at negative 2 you have to cross, so you're going from above to below. And then we have next in line. Okay, so we have x equal to -1. And at -1, now it's going to touch the x-axis. So starting below, then you have touching, and you have back down below. And we have now our next x point. Now we have x equal to 1. But before we get to that, we have our y-intercept at y is equal to -2. And then situating our remaining x-intercept. So we have at 1. And again, so this time we have rising to the right. And so we have, so we're looking at, again, crossing, touching, and then once we get over to here, we have crossing from below to above. And so just tying in together what we have now, we have the appearance of this particular graph. So you have all intercepts for the x and the y. So you have cross, touch, then you have the y-intercept. And once we get x equals 1, the graph is going to cross. And so as we check the result, bingo. Still on section 2.2, it says to consider the following polynomial functions, okay, for g of x and h of x. And it says to choose the graph of each function from the choices below. So we're looking at which of the graphs will match up with g of x and h of x. Okay, first of all, if we look at, let's say for g of x, okay, here we have is equal to -x to the 4th minus 3x cubed. All right, now we have for the highest degree term, let's say we have h dt, highest degree term, so we have -x to the 4th. So we have, in this case, we have with the leading coefficient, a of n is equal to -1. So you have a negative, and we have for the degree n, you have n is equal to 4. So you have to end up being even. So we have, at least for the n behavior, okay, so you're going to have down to the left, down to the right. Okay, all right. So right now, let's say for the graph that ends up going down to the left and down to the right. So it's not going to be A, B, C, or D, but we still have possibly graphs E and F. So it's going to come down to either E or F. And so once again, we have with g of x equal to -x to the 4th minus 3x cubed. So if I factor out the negatives, I have the negative of x to the 4th plus 3x cubed. And if I factor even further, greatest common factors, I have x cubed into x to the 4th plus 3x cubed. That's going to be at x plus 3 okay. So we have with the zeros. Okay, so you have with the x factor. Okay, first factor, okay, we have x is equal to 0 from x plus 3. I have x equal to -3. And we have with the multiplicity, okay, x equals 0 has a multiplicity of 3, since that stems from x to the 3rd. X equals -3 stems from just x plus 3, which you would say would be to the 1st. And correction, x equals 0 stems from x to the 3rd, which in this case signals that 0 has a multiplicity of 3. And since we have odd valued multiplicities, you're going to have to cross at both x is equal to 0 and x equal to -3. So again, we have the in behavior have down to the left, down to the right, and we have at both 0 and -3. And so at -3, okay, this touches, but at -3, the graph is going to cross. So E is out of the picture. So we have F to be our result. So you have crossing at -3 and also at x is equal to 0. So in this case, all right, so for the first function, okay, the choice is going to be F. Now, for what we have in the case of the function h of x, so you have h of x, so we have -2 times, okay, the square of x minus 2. And we have times quantity of x plus 2. Now for the end behavior, if I look for the highest degree term, okay, so you have with our factors, so you have -2 at the front, then we have x, which will be to the second higher degree term. We have in x plus 2 is going to be x, so I have for the highest degree terms, I have -2. We have times x, which will be squared, and we have times x once more. So we have -2 times x squared times x. Highest degree term, if you were to multiply out, we would have -2x cubed. So we have with the leading coefficient, we have -2. So that is negative. And we have for the degree of the expression, okay, signaled by -2x cubed, we have n is equal to 3, so you have to be odd. And if you have a combination of negative and odd, the end behavior is going to be up to the left and down to the right. So you have up to the left, down to the right. So A is not possible, B is not possible, C, however, is, D is also possible, and graphs E and F are not possible. So you have up to the left, down to the right. And in terms of which of C and D is going to be the one that defines or represents the function h of x. So it's going back, so you have h of x, have -2 times the square of x minus 2. You have times the quantity of x plus 2. And we have, in the case of the zeros, from x minus 2, I have x is equal to 2. For x plus 2, I have x is equal to -2. And we have, now for the multiplicities, and so we have, for the multiplicity, we have x equals 2 stems from x minus 2, which is raised to the second. X equals -2 stems from x plus 2, which is to the first. Okay, so for x equals 2, the multiplicity is even. So you're going to have the graph to touch the x-axis at x is equal to 2. And since we have -2 with an odd multiplicity, it's going to cross at x is equal to -2. So crossing at -2 and touching at +2. Okay, now you have crossing at -2 and crossing at 2 for graph D. So A, B, D, E, and F are eliminated. So graph C in behavior have up to the left, down to the right. And we have crossing at x is equal to -2 and touching at x is equal to 2. And so the result is going to be graph C. And checking the result in this case, while it's thinking, checking out. And the result is correct. Okay, for what we have in number 6, okay, we have this function f, and it's asking is decreasing over which intervals. It says to choose all that apply. Now the intervals, we're looking at the x values. Okay, so if you notice we have an increase since the graph is rising, then we have a decrease. And this is going to fall between but not including -8 and -5. So this is one location where we have the decrease, then we have an increase until we get to x is equal to -1. And then once we look at this, we have decreasing again. So we have going past -3, approaching 3. And then we have, for the last decrease, you have between 7, but not including 7. And we have 9. Okay. Now, it says the function f has local minima at which x values. Okay, and what we mean by local minima, this is where we're going to have the dips. Now, if I were to look at the local maximum, like each maximum point, you're looking at the peaks. Now, for what we have in this particular case, where we have local minimum, looks like we'll have at -5, also at 3, and also at 9. Okay, so I have -5, 3, and 9. So just lining up. What we have here is they have -5, 3, and 9. And in terms of the sign of the leading coefficient of f, remember the in behavior, you have down to the left, up to the right. So in this particular case, for what we have down to the left, up to the right, that means that, okay, we're going to have an odd-powered function. And in this particular case, all right, we're going to have the result to be positive. So you have a positive leading coefficient. Okay, and now just for what we have in the graph itself, I'm just going to mention, you're going to have in the illustration what will be referred to as turning points. And now for what we have here, so just sort of sketching the behavior of the graph of this particular function. Okay, now we have what will be referred to as turning points. So you have 1, 2, 3, 4, 5, 6. So you got 6 turning points. And now again, you have your A of n is going to be a positive coefficient. Now, for your value n is going to be odd. And it's going to be an odd value that is going to be more than the number of turning points. Okay, so the turning points will be, number of turning points will be at least 1 less than the degree of the function. So in this case, if you're looking for an odd value, more than 6 turning points, so n could be 7, 9, 11, and so on. And it looks like for the possible degree that we had to choose from, now we have an odd power function with 5, but that does not equal the number of turning points. So if it's equal to or less than, it's not included. But since 7 and 9 are values greater than the number of turning points, those would be the selections. And checking the results here. And that is also correct.